Okay, in this session I'm going to go through buffers of a required pH, which is part of the A-level course. These are the examples that I'll go through. So example 1 and example 2, and then you have an exam question at the end. So make a buffer solution of pH 5, or make a pH buffer solution with a 9.55. Both are very similar. One involves having ethanoic acid and the other involves having ammonia. So the first example, question 1, they'd often provide you with a Ka value, a pH that you need to get to, and probably tell you some ingredients like ethanoic acid and sodium ethanoate, which are both needed in order to make a buffer. And the start of this, most students will get the first mark, which is to work out the hydrogen ion concentration, which would be inverse log minus pH. So if you did that, the pH is 5. So inverse log minus 5 gives you 1 times 10 to the minus 5. And then if you start rearranging the expression Ka equals H plus times A minus over HA, you would have Ka times HA equals H plus times A minus if we times both sides by HA. Dividing both sides by Ka will give us HA equals H plus times A minus over Ka. And then dividing both sides by A minus will give us HA over A minus equals H plus over Ka. We have currently the H plus concentration and the Ka value, and then students might get to this point but then not know what to do because you're missing one of the other bits of information perhaps to get one of those items, HA or A minus. So most will get just the 1 mark. At this point, you need to understand what the maths is trying to say. So 1 times 10 to the minus 5 divided by 1.74 times 10 to the minus 5 is going to tell you, which is H plus over Ka, how much weak acid HA you need per 1 of A minus. So if you do that, we get 0.574. So that means for every 1 of A minus, we need about half the amount of HA, and all that matters is this context. So in order to get a pH of 5, the weak acid has to be 0.574 times that of A minus, which basically means almost half of that for A minus. All that matters is the ratio. If you were to do 1 divided by answer, you would get it the other way around, the reciprocal. Or if you did Ka over H plus, then that would come out about roughly twice as much. So that would make sense in the sense of we need twice as much of A minus in comparison to HA, which is the other way of looking at it. So about half the amount of HA to every 1 A minus, or twice as much A minus roughly compared to HA. So depending on how you rearrange the equation, you might get either one of these. What matters is the per 1 for every 1 of A minus, or per every 1 of HA. So example 2 was a buffer solution was made by mixing 50 centimetres cubed of 0.2 aqueous ammonia with 50 ml of aqueous ammonium chloride. And this is another way of making a buffer solution with a pH greater than 7. So it's more of an alkaline pH. The pH of the resulting solution was 9.55. So inverse log that gives us straight away H plus is equal to 2.818 times 10 to the minus 10. Then it's actually important to understand what this relationship is with ammonia and ammonium chloride, as most will recognise that Ka is equal to H plus times A minus over HA, and may not know where ammonia and ammonium fit in this. Well, ammonium is a weak acid, as also said by the Ka. So that's our HA. So that's the same as saying if we were going to put ammonium chloride, ammonium here, as being our HA. Chloride is just the spectator. So Ka is equal to H plus times A minus, but in this case we're going to say that the equivalent of A minus, our base, is going to be ammonia, because ammonia is a base. So I'm going to write NH3 there. So you can view it in that context. So the A minus is effectively that, as what we're used to. So ammonia is our base. So Ka is H plus times ammonia over ammonium. We're going to get an answer of Ka over H plus, or H plus over Ka, however way you do it. So in this, if we do Ka 5.62 times 10 to the minus 10 divided by the hydrogen ion concentration, you're going to get an answer of roughly 2 to 1. So that means we need twice as much of ammonia compared to our one lot of ammonium. So at the beginning, the question said we need to have the proportion of 0.2, we want 0.2 concentration in 50 mil. The volume hasn't been asked here, but in order to have that, we need to mix two solutions together where one of them is half the concentration. So ammonium chloride has to be 0.1. And however we want to mix that in total volume, the question here is asking for get 50. So we need twice as much ammonia compared to ammonium chloride in order to achieve that, to get a pH of 9.55. All that matters is that ratio. And in the exam question, you'll see how to do that with the context applying to the volume. So now I'm ready for an exam question. If you'd like to pause the screen for this and have a go and go through the answer. Okay, I'm now going to go through the answer. So 500 ml of a buffer solution of pH 4.7 is required. Calculate the volume with a concentration of 0.8 sodium ethanoate solution and of 0.8 ethanoic acid needed to make that buffer. If you did inverse log minus pH, that would have been usually the first mark students get. 1.995 times 10 to the minus 10 is going to be your hydrogen ion concentration. H plus over Ka is HA over A minus. So if you did 1.995 times 10 to the minus 10 divided by 1.74 times 10 to the minus 5, you're saying H plus over Ka is for every ethanoic acid per 1 of sodium ethanoate. You could have done the other way, that's fine. So doing the hydrogen ion concentration over the Ka gives us, for every 1 of the salt, you need 1.1467 times of the ethanoic acid. So as a percent, that would be around 53% if you were to take the total as being the combined as 2.1467. So 53% of 500 ml will tell you how much ethanoic acid you need, and that's going to be 267 of the ethanoic acid, with the remainder being 233 for the sodium ethanoate. And so that's the proportion we need to mix together to make 500 ml to achieve a hydrogen ion concentration of 1.995 times 10 to the minus 10, which would then give us the pH of 4.7 in our buffer. So that's how you do the question. Good luck.